Okay, well, today we get to start chapter 14. We will be talking in this chapter about types of mixtures. So we will be talking about some of the different terms that you learned first semester. So heterogeneous mixtures, homogeneous mixtures, solutions, colloids, all of those things we're recircling back to and just discussing in a little more depth. All right, so in chapter 14, section 1, we're going to try to define these certain types of mixtures and distinguish which one is which. So the first thing you'll have is a heterogeneous mixture. In a heterogeneous mixture, remember that prefix hetero means different. So in a heterogeneous mixture, you can see the differences, right? So this is that thing like Italian salad dressing, the sand on the beach, where you can see the different particles and their different colors and their different sizes. And no matter what, each particle remains distinct, right? So one of the types of heterogeneous mixtures that we're going to focus on is what's called a suspension. A suspension. It's just defined as mixtures containing particles that settle out if left undisturbed. So this is things like Italian salad dressing. So if you think of Italian salad dressing in a bottle in your fridge, every time you pull it out to put on your salad, you got to shake it up. That's because as you let it set, those big particles of herbs and spices will settle to the bottom, and the less dense oil will rise to the top. And so you want to shake it up to mix it all together. So this is an example of a suspension. Large particles. It is a heterogeneous mixture. You need to identify suspensions are heterogeneous mixtures. Then we'll have colloids. Now, colloids are heterogeneous mixtures, but their particles are a lot smaller than a suspension is. And if you let it sit, a colloid's particle won't settle out. It will stay kind of a little bit more uniform throughout. So many people will think of a colloid as looking like a homogeneous mixture. And so that way colloids can get a little bit confusing. The main difference between a suspension and a colloid and a homogeneous mixture are the sizes of their particles. So suspensions have very large particles, colloids have medium ones, and when we talk about solutions or homogeneous mixtures, they have the tiniest particles of them all. A great example of a colloid is unpasteurized milk. So the milk that they come straight out of the cow, right? Because you've got your different fats. You've got your butter fats. You've got your curds. You've got your whey. All of that stuff is processed out in the milk that we drink from the grocery store. So we only get part of that colloid that milk really is. All right, here is a chart. It's in your book. It's got all sorts of different colloids in it. As you can see, common things like blood, milk, marshmallows, smoke. Even, I want to point out this one right here, fog is a colloid. And we're going to come back to that in a minute when we talk about a way to tell the difference between a colloid and a solution. So what I was referring to is this way of being able to tell the difference between a colloid and a solution. And what that is it's called the Tyndall effect. And what the Tyndall effect is when you shine a light beam through a colloid, you see the beam. Where if you shine the light through a solution, the light goes right on through and you can't see that beam. In fact, we talked about this last semester when we talked about why lighting guys for churches and concerts will put haze in the on the stage. It's so that you can see the beams of their light that much better and more dramatic. And that's all because of this Tyndall effect that happens in colloids. All right, the only homogeneous mixture, and you already know a special name for that, is a solution. A solution has the smallest particles, right? And it always has something called a solute and a solvent. And we're going to talk about that a little bit. Okay, so couple of vocabulary words you need to know. If a substance dissolves in a given solvent, okay, so the substance that's being dissolved, that is what we call the solute. And the substance that's dissolving that solute, we call that a solvent. If the substance gets dissolved by the solvent, we say that it is soluble. If it doesn't get dissolved, then we say insoluble. We can also use term miscible. So if it's two liquids instead of like a solid and a liquid, but if it's two liquids that are soluble in each other, we say that those liquids are miscible. If they are not soluble, then we say they are immiscible. So some terminology you need to be aware of. All right. So what I want, I want you to watch this video real quick.
Hey guys, Frenchos Philip here, and today we're going to talk about the Tyndall effect. Named after 19th century physicist John Tyndall, it is an easy way to determine whether a mixture is colloidal or not. A colloid is a mixture with particles between 1 to 1,000 nanometers in size. Every colloid has two parts, the dispersing medium and the colloidal particles. The dispersing medium is the substance which the colloidal particles are distributed. For example, in muddy water, the dispersing medium is water, while the colloidal particles are the grains of sand and clay. And yes, I'm sitting down on the floor. For this experiment, we're going to need two glass bottles, one filled with water and the other filled with water and some soap. We're also going to need a flashlight. As you can see, when light is shown through the bottle with water, you can't see the beam of light passing. Moving to the bottle with the soap and water, you can see the beam of light passing through the bottle. This is what's known as the Tyndall effect, and it is caused by the reflection of light by very small particles in the medium. In this case, it's the soap particles in the water. Anyway guys, that's gonna be it for this video. If you learned something from this video, leave a thumbs up and make sure to hit that subscribe button down below.
Okay, so what you got to see here is what we were talking about, a very common tool to decide whether a solution is a solution or if it's actually a colloid. Having those little bit bigger particles than what the solution does, not as big as the suspension. This is why when you learn to drive, one of the things in driver's ed is for you to not use high beams when you're going through fog, right? So fog is a colloid. If you have your high beams on, these bright light, it gets scattered through the fog and it actually does you no good. You want the low beams that are down on the ground so that you can see some in the fog. All right, so that'll be it for today's, or for this part of the videos. You can check out more information on any of these things in chapter 14, section 1 of your textbook, and I will talk to you later.